end behavior models. You can predict the end behavior of a complicated polynomial by looking at the simpler one that acts exactly the same way for large values of x. So basically, we're going to take a complicated function and we're going to determine a more basic function that's going to model the same in the end behavior. An example of this is for all polynomials where f of x is equal to the definition of a polynomial, which is a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a naught, where a naught is a constant. We have that g of x is equal to a sub n x to the n as an n behavior model. And I'm going to show you exactly what I mean when I'm talking about this. So for example, if I take this function, which is represented by 5x to the fourth plus 13x cubed minus 22x squared plus 1. This has some crazy looking behaviors. So I'm just going to zoom in a little bit so we can see what's going on. But overall, it looks like it's a parabola with a couple little divots in it. Now, I'm going to just take the graph of 5x to the fourth, which is just the first term, and graph it right on top. So as we're zoomed in, we can see they look kind of the same. But as I start zooming out, as the x values get larger, you can see how they start to overlap each other. The definition for an end behavior model is as follows. The function g is a right end behavior model for f if, as the limit as x approaches infinity of f of x divided by g of x is equal to 1, where f of x is the original function and g is your end behavior model. A left end behavior model for f is if the limit goes to negative infinity, then f of x divided by g of x is also 1. So you know you have a behavior model when the function, as you let x goes to infinity or negative infinity, you get 1. In example 6, we're going to show that g of x, which is equal to 3x to the fourth, is an end behavior model for the function 3x to the fourth minus 2x cubed plus 3x squared minus 5x plus 6. This is very similar to the graph I just showed you because they were both fourth degree polynomials, just with different numbers. So first let's start with the right end behavior model. And so we're going to get, this is the limit as x approaches infinity of f of x divided by g of x. So this is going to be then the limit as x approaches infinity of 3x to the fourth minus 2x cubed plus 3x squared minus 5x plus 6, all divided by 3x to the fourth. And so the way you do this is, one way is to divide everything by 3x to the fourth, or you can just split up the fraction. So I rewrite this as the limit and now what I'm going to do is go ahead and simplify. And then I'm going to take the limit of everything. So the limit for the first one is going to be 1. This is going to be 0 because you get 1 over infinity. This will be 0. This will be 0. And this will be 0 because they all 1 over infinity. So this equals 1. So I've shown it's a right end behavior model. And you would apply the same thing by doing it with negative infinity. So based off this, we can write the conclusion g of x is equal to 3x to the fourth is an end behavior model for f of x is equal to 3x to the fourth minus 2x cubed plus 3x squared minus 5x plus 6. And if we go ahead and look at the graphs, we can further analyze what's going on here. So if I look at the graphs when they're zoomed in, where this is g of x and this is f of x, they look very different. However, when they're zoomed in together, they look exactly the same. And you can see how they both have the trend of going up towards infinity.